Hi, so this will be the last subtopic before your internal test 2, and this is taken from your unit 4. The name of the chapter is prefabricated slash precast construction. Okay, as the name suggests, you are not casting anything on the site. Even if you are casting something on the site, you do it in the place called a yard. So people must have seen these bridge being constructed around. You will see that their girders and their deck slabs are casted in the yards and then they are transported on to the place where they are finally supposed to be placed. So it's not like you have props and you have form work and in that you're pouring the concrete. And then wherever you require the final placement of concrete, there itself you make a formwork and you pour it. Now this is a different way. This is either you cast it in the yard or you can even cast it in the factory, in which case it's called prefabricated. So you fabricate it in a factory or any industrial outlet and then you transport it. Now this is a topic which was earlier handled in a subject called low cost housing. So how is this particularly becoming low cost or affordable? Okay, there are a lot of advantages of prefabricated and precast construction. First is the construction time. Okay, you are not making formworks and you're not actually deploying labor, especially when it comes to prefabricated. Okay, so on your site, you directly get the ready-made element, and all you need to do is place it in its position and probably join it to the other elements. So the time that is required for casting, the time that is required for hardening, all this gets eliminated. Then you don't require to stack the material on the site, so you don't need a storage place. You don't need, otherwise what happens if you remember when we were studying the cement and all this, even timber and these particular materials, they require a special way of even storing. They are very vulnerable to environmental attacks. You cannot store cement in a place where there is moisture, there's a lot of humidity. You can't stack it in such places. Similarly, even wood and all. So everything, all the building materials, they require you cannot just keep it at the side of the road when your required quality of construction is high. So basically this entire need of stacking is less. Also when you construct something using prefabricated or precast items, okay, the quality of check is way much better. Okay, especially when something is casted in a factory, it will be definitely under the supervision of engineers. Okay, unlike when you see a lot of projects, you will not find engineers on the site many a times. So this doesn't happen, and because of that, the wastage in materials also reduces. Next is manual labor requirement. Since most of the units that are prefabricated or precast, okay, they are manufactured using machines. The manual labor requirement goes down. Also, as I told you, the supervision is of a better quality, so you get the better quality elements used in construction. And again, since you're not storing it at the site, or even if you're casting it at the yard, the period of storage is very less. This entire methodology becomes a little more weather independent. See, otherwise what happens if you are casting something on the site, say you're casting a slab on the site, the moment it starts raining, you will have to stop the work. But this doesn't happen if you are going to use precast slab panels or hollow panels, or you're going to use precast joists. Then in that case, you don't have to wait for rains to subside. You can go ahead with your work. All you need is to get the panels and place it in its position. The limitations. Now, of course, everything has limitations also. Limitations is now, since you're going to use something which is factory casted or maybe casted separately, there will be a limitation on the sizes. You will have to decide on the sizes which are available. It's as good as, you can compare it to your clothes which you are getting stitched from a tailor and ready-made garments. There will be a limitation when you are in situ on the site. Casting is something like a tailor-made job. It will be exactly as per your requirement. That doesn't mean your ready-made available garments don't fit you, right? But you will have to select from the number of sizes that are available, maybe XS or small or M or XL. You can't get something which is exactly going to fit you and not going to fit anybody else. That becomes difficult when you're going to use ready-made garments. So similarly in this, you will have to choose the element which is manufactured or which is ready at the yard. Okay. So, because you're going to repeat the same formwork again and again. What is formwork? I've been using this word very often. I hope you all are aware of what is formwork. Formwork is basically, when you pour concrete will take the shape of the mold in which you're pouring it. So that mold, which is usually made up of plywood or timber, is called formwork. So basically in case of precast technology, most of the elements will be of the repeated dimensions. You do not change the sizes of the elements, whatever may be the element. It may be a walling unit, it may be a flooring unit, or it may be a column, anything. Usually the formworks are used are repeated. Okay, so there will be a little bit of limitation on the size and the weight. Then again, you can't cast something very heavy because there will be transportation difficulties. You cannot, if you have seen those girders, which bridge girders, you might have seen recently a lot of bridge construction happened in our state. Moving on the road, you have seen they travel at such slow speeds. In fact, they cannot accelerate because they are carrying this hundreds of tons of weight. If they accelerate and by chance the brakes fail, then there can be a lot of dangerous situation on the road. So, based on the availability of the transportation, meaning the trucks available, okay, similarly lifting, transportation and lifting, this is actually, even when you cast something very heavy, to place it, let's say at first floor level, second floor level, okay, you need cranes. Again, so when you need cranes, what I have heard from the recent reports is these cranes and all, and the trucks, those heavy trucks which carry the girders, okay, 100 tons of weight being lifted, their higher charges are more than around 60,000 and all per day. So that is again a constraint. Then interconnections of the members. You are getting two ready-made units and then eventually they have to work like a one whole structure. So what is most important is the interconnection between the two members. The load applied on one member, how it is transferring it onto the second member, that will decide the overall strength of your structure. So that is very important. So interconnections, if they are not handled properly, then there can be problems. Structural problems. And architectural problems will be these leakages. Wherever there is a joint, there will be leakage. And these leakages need special attention, which otherwise in case of cast in situ construction, that is very, in cast in situ construction also we see leakages, but the number of joints in cast in situ construction is way lesser as compared to the ones in precast technology. Now there are basically three classification systems: small, medium and large, then total and partial, and open and closed. So what is meaning of it? Now the first classification system, small, medium and large, this is based on the degree of prefabrication. Meaning, in the entire structure, how many units are prefabricated? Let's say you have only lintels which are prefabricated. You are not casting lintels. You are bringing them and placing them directly on the side. Only lintels are being used, and you will say it is a small degree of prefabrication. Let's say you are having a flooring, but in the flooring you are using small panels. You are keeping them over joist. Joist, J-O-I-S-E-S, are basically small beams. Okay, so you have a crisscross network of beams, and in between you are keeping the precast panel, flooring panels, then you can say it's medium degree of prefabrication. And if the number of panels which are put in the entire flooring are very less, or let's say you are making directly a hollow slab which is precasted and you're just directly placing it onto the supports, then it becomes a large degree of prefabrication. Then we have total and partial prefabrication. Now when we need to have very fast construction, usually all the components are prefabricated or precast. You just bring them on the site and place them and interlock them. Except the foundation, everything is precast. In that case, you call it total prefabrication. And partial prefabrication will be mainly talking about roofing and flooring units will be prefabricated. Walling, columns will be casted on the site and then interconnected to the roofing and flooring units. So half of the thing is cast in situ, half of the things is prefabricated. In that case, you call it partial fabrication. Then we have something called open prefabrication and closed prefabrications. So basically, it's based on the use of basic structural elements. Okay, so which are the structural elements, like say RC joists, then you have hollow slabs, then you have lintels, then you have walling units. Okay, so say you're constructing a house and you're going for this open prefabrication, then what you will do, you will go to the person who is prefabricating all these different elements that you need in your house. Okay, and you will choose the sections which are available with the person who's selling it. Okay, he's not manufacturing something for your requirement. He's telling you these things are available in my shop. Not shop exactly, but I'm manufacturing these elements. You see which ones are useful for you and based on that you construct your project. Okay, whereas in closed prefabrication, the manufacturer will produce components which are required by your project. So now if you're going for a house, you cannot go for closed prefabrication because no company is going to produce elements only for one house. Closed system of prefabrication is basically used for the projects where the plans are repetitive. Let's say you're constructing a health center. Now health center plan everywhere in the state of Goa can remain same. So a person who's prefabricating these units, he can manufacture this exact same size of beams and columns and all for one particular plan because that will be again used somewhere else. So his molds, his casts are being used again. So closed prefabrication system is only justifiable if the size of the project is large. Meaning you are constructing a lot of health centers, a lot of schools or anything typical. And the architecture is having a reputation. Or maybe it's a symmetric plan or it's a plan which is going to be adopted everywhere. And there has to be sufficient demand. So although let's say all the schools can have same plan, but there have to be many schools first and foremost. If you're going to have the project only in one place, just because the plan is repetitive or just because the size of the project is very large, but it's just single project, you cannot go for closed prefabrication. Now these are the elements used in prefabrication. Okay, so you can see here we have a flooring element. So this is a mold. Now when you see this, you should realize this part is elevated. It is little bit on top. So this is elevated and this part is very much low. So what is usually done is you keep these panels next to each other and then you start pouring concrete on the lower part. So all this part will have concrete, this part. Okay, so you will keep these adjacent to each other and on this part there will be concrete and there will be some nominal steel also inside. Okay, so I can't enlarge this. If I could, I would have been able to show you how it is exactly done. So here there will be one panel, then another panel. So this will be adjacent to another panel. So here you can see white part. In that white part there will be concrete grout poured and there will be nominal steel also. Yeah, going ahead with the last part in prefabricated elements and just quickly cover the types of elements. So we had just seen what is this flooring unit. So basically what happens in this flooring unit is, I've just drawn a schematic diagram. So this is the same panel. The width of the panel is around 1.5 meter by 300. And if you see the thickness, it's just 30 mm here. And additional 30 you can see. So you can see this entire part is there. No? This entire part is like elevated on top. And this is sloping downwards. So you see this is a triangle. This is a triangular thing. So this entire thing is sloping downwards. This comes totally on top. So 30 plus this is another 30. So what is the thickness of this slab panel? It's just 60 mm. 60 mm is 6 centimeter. What is the thickness of the slab on which we are walking now in the college? The college slab is nothing less than 16 centimeter. Okay, it's very 6 centimeter and 16 centimeter. So that's why this comes as a part of, people have to even study this as a part of affordable housing techniques. Now, this 1.5 is laid like this. Now, this is your wall, okay? This is your wall. And then this from here to here is 1.5. And this 1.5 is then later on kept on a precast joist. What is a joist? Let me show you. Here, you can see this. This is like a beam, but this is way much smaller. The dimensions are 15 by 15 centimeter. What is the beam width that you have in your college, in your classroom? It's nearly around 30 by 60. Okay. So these panels are then eventually placed on these beam joists. So these beam joists will have steel like this. So you have steel here. It's way much above. Not able to draw properly. So then once all these panels are placed like this, here there will be concrete poured. So here there will be concrete poured. That's how then it becomes monolithic. It has to be fully nicely joined. You're keeping so many. At 1.5 meter you are placing a joist. What is the distance at which you have placed the beam in your classroom? Is somewhere around 3.5 meters. So at every 1.5 you are placing a joist. Okay. And then since this all lower part is there, so here there will be a additional steel provided. There are steel rods provided here, which you will see here. Like this you will see in the cross section. And then all over this it will be leveled by pouring rich cement grout over it. Concrete, sorry, not grout. Cement concrete will be poured over it. Okay, so like this. This is called a precast floor slab. Okay, now let's go ahead with the next. Here you can see the different types of joists. Here there is a joist, and this is the precast slab, the same one what I showed you. So how it will look. And then here there will be concrete poured. Here there will be concrete. So this hook which is there on top, that also will go submerged into concrete, and then everything will be at the same level. Okay. Then we have columns. There is nothing to show in columns. Precast columns you get. And then you have brick panels. So you can see this is a brick panel taken from a research paper. So there is this institute CBRI from IT Roorkee. They do a lot of research in low cost affordable housing construction. So this is one publication that I have got on the internet. You get it free of cost. You can just check this. Okay. So what is this basically? There are lots of bricks. You can see they are kept nicely arranged, and in between there is cement concrete poured. Okay, this is sometimes even provided in the arch form. So you can see this, what is this gentleman doing? He has kept some bricks, and in between there are, see here you can see from down. This is the roof, from down how it will look. And you can see he has placed it on the RC joist. Hardly any thickness, just around 15 centimeter thick beams these are. And in between bricks. Brick is not a very costly material, and hardly any concrete is being consumed. So these are very nice, good looking, low cost construction techniques which you can use when you actually start practicing. Okay, so this is a brick panel. Then alright, I guess, then did I explain this? Yes, these are hollow slabs. Okay, these are also used for flooring. They are also very sturdy. So you are removing the part of concrete which is not getting stressed, which is not participating in any kind of load transfer. So that is removed. These are different prefabricated elements. Okay, so we are done with the prefabricated subtopic also. Prefabricated and precast subtopic.